Welcome to everybody. This session is going to be directly recorded to YouTube. As I'm running low on space on the computer to record that before sending it to. All right, so 2 ways to go today. I can either get your questions that I answer on all the topics that I listed, or if I don't get questions, I just go ahead and do whatever comes to my mind on each of the topics that I see.
I was looking over some of my stuff for test 1, and it was a problem or a question 2A. One of the steps really threw me off, and it was
Just launch the question.
okay. It was x dx plus y minus 2x dy in parentheses, and that's equal to 0.
And the topic was?
It was solved using or solve the homogeneous equation.
So that's the topic.
Yeah, so it was you substitute y equals ux. And for dy, it's x du plus u dx. That's like our thing for that.
So that's first order homogeneous equations, which is one of the topics that you surely have on the final exam. And how do we solve first order homogeneous equations? You just said we put y equals x dx y equals ux, and then we find dy. So here, if we want to solve this, we are going to say y equals ux, and then find dy using the product rule, because u is a function of x. So that's going to be x du plus u dx. That's applying the product rule to find the derivative of ux. And then you take those two into the equation. So that's x dx plus y, that's ux, minus 2x, and dy, that is x du plus u dx equals 0. So after doing this, what you need to do now is to get the terms that have dx together and get the terms that have du together. So that's x dx, all of this times u dx. So that's plus ux minus 2x u dx, and then everything else that has du, and that is all of this times x du. That's ux minus 2x x du equals 0. Combine these terms, that's x minus u squared x minus 2x u dx plus, that's going to be, we can factor out here and have u minus 2 x squared du equals 0. Now we can factor out here 2x, that's x. We can actually put minus x out there. So that's going to be u squared and by the way, why is it minus here? This is plus, right? U times u, that's plus u squared minus 2x times u. Okay. So it's going to be u squared minus 2u plus 1 dx plus u minus 2 x squared dy du equals 0. And here we can simplify by x. And this here is u minus 1 squared. So that's u minus 1 squared dx plus u minus 2 x du equals 0. And now this is a separable equation, which is another topic of this test.
So what happened to that x in the previous line? You said simplify by x. Does that just mean taking it to the other side, and that way you
divide the whole equation by x. X got canceled here and x squared became x. Like I was saying, this is a separate topic of this test as well. Need to know how to solve separable equations. And how to solve a separable equation? Separate the variables. Get all the things with u on one side, all the things with x on the other side. So here, I keep u minus 2 du x here, and I send the other part of to the other side, minus u minus 1 squared dx. Divide by u minus 1 squared and divide by x, you get u minus 2 over u minus 1 squared du equal negative dx over x. Now your variables are separated, and after separating the variables, you need to integrate on both sides. So you bring the integral on both sides, and then you integrate this one. These are partial fractions. So that's integral of 1 over u minus 1 minus 1 over u minus 1 squared du equals negative integral of dx over x. Why is that? Because this is u minus 1, they cancel. You get 1 over u minus 1 over u minus 1 squared. Now when you integrate this is ln, absolute value of u minus 1. And this is 1 over u minus 1 equals, and this is negative natural log of x. And I can write cx. Right. And the next thing you do is replace u by what it is. U is y over x. So that's what you get. Then you can continue simplifying this if you want. Questions? Any questions about this? Any other questions? So suppose we have a problem like this one. Now we need to solve. So what would be your guess of the first step here? First of all, how is this kind of equation solved?
I can't quite remember what it's called, but I can tell it's not in proper form because you have something in front of your dy dx. So your first thing to do would be divide everything by x.
That's correct too, but there's another step that needs to be before that, depending on the type of problem that we have. That's a specific type of equation in this class though. Do you want to say something, Mr. Kemper?
No, because I don't think my guess is right.
Is Daniel with us there?
Yes, I am.
Yeah. Any guess for this one? What type of equation is it? That's called Bernoulli equations. And to solve this kind of equation, you need to know what's the general form. The standard form, you want to see dy over dx plus p of x y equals f of x times y to the power n. So in this case, that's going to be dy over dx plus 4 over xy equals x minus 1 times y squared. And that is obtained by dividing both sides of the equation by x, which is the coefficient of dy over dx. Now in step 1 in there, all you need to do is divide the equation by y to the power n. And so w equals y to the power 1 minus n. Use dw over dx equals 1 minus n y to the minus n dy over dx. So in this case, that's going to be 1 over y squared dy over dx plus 4 over x y to the minus 1 equals x minus 1. W equals y to the minus 1 dw over dx equals minus y to the minus 2 dy over dx. So this, which is right here, is minus dw over dx. And then you use that y to minus 1 is w equals x minus 1. Anytime you do that, this problem goes down to a first order linear, which is the previous, related to the previous problem we just solved. So how do you solve the first order linear differential equation? You make sure the coefficient in front of dw over dx is 1. So solving the obtained first order linear problem, we're gonna get dw over dx minus 4 over xw equals minus x plus 1. Multiply both sides by -1. Now what needs to be done in this problem is, in solving linear problems, the first thing is find the integrating factor. Which is mu equals e to the integral of p of x dx. P of x being what you have right here in the equation. Not in that original problem, but right here in this equation. So here we are going to find mu of x equals e to the integral of -4 over x dx, which is e to -4 natural log of x, which is e to the natural log of x to the -4, which is equal to x to the power -4. That's the integrating factor. And the next thing to do after finding the integrating factor is to multiply the equation by the integrating factor. And combine the terms on the left. As d over dx, mu of x, and y. So when you do that, here you get mu of x, x to the -4, y d over dx is going to be equal to minus x plus 1 times x to -4, which is minus x to -3, those x to -4. So you combine the terms and you multiply the whole thing by x to -4, that is the integrating factor. And the next step is to integrate. Integrate both sides. In this case, when you integrate the left, you get x to -4y. When you integrate the right, you get negative. Integral of x to -3 is x to -2 over -2, so it gives you 1 over 2x squared. And the integral of x to -4 is x to -3 over -3, so that's -1 over 3x cubed plus the constant of integration. And there's problem right there. So in this problem, I was writing as if it was linear. The function is w, so that was mu times w. And that's mu times w. And so here you're getting mu times w, not mu y. And it's after you finish that you bring in the y being w to the power 1 minus n. So you bring y over x here. You're going to be having x to the minus 4 times 1 over y, because that's w equals 1 over y, equals 1 over 2x squared minus 1 over 3x cubed plus a constant, from which you can get 1 over y equals 1 over 2 multiply both sides by x to the 4th, so it's going to be 1 over 2 times x squared, because x to the 4th over x squared, that'll be x squared, minus x over 3, when you multiply by x to the 4th plus cx to the 4th. So this unique problem, actually, it turns out to include 2 other problems. Questions?
Would you mind going over when you substitute y equals or w equals y to the 1 minus n? You set that equal to, I mean, you say y equals w equals y1 minus 2, since your y squared is in the equation itself.
Yes.
And then you take the derivative of that.
Yeah. What's the question? Hello?
I'm trying to figure out what my exact question is about that. When do you use the derivative of that?
That's it circled here, written on top and used here. Y the minus 2 dy over dx, that's it right there. That's minus dw over dx, that's why I have it here. Any other questions? So the other type of equation that we had was exact equations.
After this one, I actually have a question about a Cauchy-Euler equation.
Mhm. So you have an equation that is exact. How do you solve an exact equation? And the first step says, call those guys. What is in front of dx is m. What is in front of dy is n. And you want to find a function f of xy such that the derivative of f of xy with respect to x equals m. So f is the integral of m dx, which is integral m is 3x squared plus y minus 1 dx, and you integrate that 3x squared dx, the integral is x cubed, y integral dx, the integral is y times x, minus 1, the integral is minus x, and then you have always a constant of integration that depends on the other variable, h of y. In your next second step, you take the derivative of what you got there with respect to y. So the derivative of f with respect to y is equal derivative with respect to y, that's x, 0, 0. Derivative with respect to y of h of y, that's h prime of y. And the method says, set this derivative equal to n of xy, and n is given in the equation, that is x minus 2 plus 2y. So this equals that. And you can solve, in the next step, you solve for h prime of y. In this case, that means send everything else to the other side. You get h prime of y equals x minus 2 plus 2y minus x, which is negative 2 plus 2y. So that's h prime of y. And then the next thing is to find h of y. You get that by integrating that derivative. That's the integral of h prime of y dy. That's integral of minus 2 plus 2y dy. And that gives you minus 2y plus y squared. and then you have a constant of integration. And the last step is you find f of xy by replacing this h of y in the obtained formula of f. So you get x cubed plus yx minus x plus y squared minus 2y plus c. And your last step, you set that equal to 0 to get the answer. And you make sure you have that constant of integration built in the answer. What was your question, Mr. Kemper?
One second, I just had it. Oh, got it. It was it's a Cauchy-Euler equation, and it goes x squared y double prime minus xy prime minus 8y equals 0. And I just wanted to see if you could go over that problem. It looks really easy, but the first.
Can you give me the problem again?
Yes, sir. It's x squared y double prime minus x y prime minus 8y equals 0. And it's assuming that x is greater than 0.
Yeah.
And that's all.
This topic is not the one that you announced. This topic is Cauchy-Euler equations. Which is very different from the equation with fixed coefficients, because here you got x squared, here you got x. And the method here, it says you got to write the equation a d2y over dt squared plus b minus a dy over dt plus cy first. Technically, you could actually have a right-hand side. Let's say even write down here with the right-hand side. And then you would have to write that this is equal to f of x e to the t. So that's the first step in those problems, because when I'm giving you that problem, it's certainly going to have a right-hand side. And when you do this, you turn this equation into that other equation where you use x equals e to the t, or t equal natural log of x. That's the same statement. You do this change of variable, it brings this equation to that equation. And now to solve this equation, you got to write down the equation equal to 0. Let's use your example. X squared y double prime xy prime minus 8y equals x natural log of x. Okay, so if I do this here, your a is 1. What is b?
Oh, wait, is b just -1?
-1. And c?
Oh, -8.
-8, that's it. So you're going to write that equation using those numbers. A is 1, so that is d2y over dt squared. -1 for b, -1 for a, so that's -1 minus 1, so -2 dy over dt minus 8 y equals x is e to the t, natural log of x is t, so that's t e to the t. And now you can solve, now this equation is second order linear with fixed coefficients, which is a topic that we reviewed on Friday. How do we handle that? Write down the Euler equation to solve the homogeneous problem. R squared minus 2r minus 8 equals 0. Again, I have many people having problems with solving quadratic equations. If you don't know how to factor out, don't do it. Because you do that with a mistake, you messed up your entire problem. Use the quadratic formula to solve it and get the correct answer. So here R12 is 2 plus minus square root of 2 squared, that's 4, minus minus plus 4 times 8, 32, over 2. 32 plus 4, that's 36, square root is 6, so that's 2 plus minus 6 over 2. That's minus 2 and 4. So the solution of the homogeneous problem is yc of t equals e to minus 2t c1 plus c2 e to the 4t. And now, because this is a special right-hand side, we can do the method of undetermined coefficients to find the answer with that right-hand side. So I want yp of x equals, that's a polynomial of degree, and yp of t, because we have t in the equation, that's a polynomial of degree 1 times e to the t, so it's going to be polynomial of degree 1, at plus b times e to the t, and then we are going to check to see if these are solutions of the homogeneous equation, to see if we should multiply by t or t squared. So e to the t is none of that, correct? T e to the t is none of those, so there is no exception here. So this is what yp is, and all we have to do now is take the derivatives, plug them into the equation and solve, and track the coefficients, and keep that on top there so we can follow on the other paper. So the equation is up there. What we need to do now is take derivatives and track the equations. And track the coefficients. So the derivative of yp, in this case, that's at plus b. Derivative of e to the t is 1. 1 times at plus b plus derivative of at plus b, a e to the t. Then you take the second derivative. Again, derivative of e to the t is 1 times that. So that is at plus b plus a plus derivative of this times e to the t, it's a e to the t. That's it. Now we track the coefficients of the functions that we see. What are the functions here? E to the t and t e to the t, that's all. So that's t e to the t, e to the t, and we want to track these coefficients along the equation. Second derivative minus twice the derivative minus 8 times the function itself equals t e to the t. So we take the second derivative. Second derivative coefficient of t e to the t is a minus 2. Derivative coefficient is a. That's the derivative coefficient of t e to the t minus 8. The original functions right here. Coefficient of t e to the t is a equals right hand side. Coefficient of t e to the t is 1. Then you write the second equation. You go to the second derivative. The constant is b plus 2a minus 2. You go to the derivative. The constant coefficient of e to the t is a plus b minus 8. You go to the original function. It's right there. The coefficient of e to the t is b equals 0. If all our derivatives are correct, then the first equation gives us a minus 2a, that's minus a, minus 8a minus 9a, so you get a equal minus 1, 9. 2a minus 2a, they cancel. So you get b minus 2b, that's minus b, minus 8b, so you also get minus 9b equals 0. So b equals 0. And so you get your answer. Yp of t equal minus 1, 9 t e to the t. And then you write down the answer. Y of t equals yc of t plus yp of t, and yc was c1 e to the minus 2t plus c2 e to the 4t plus yp minus 1, 9 t e to the t. And now, because the problem was in terms of x, you got to return the answer in x. So you know that t is natural log of x. You can replace that everywhere you need it. So this gives you c1 x to minus 2 plus c2 x to the 4th minus 1, 9 x natural log of x. The same problem could be solved using variation of parameters. I hope this answers more than your questions, Jos. That's it, done for me. There's 2 minutes left. If you have something to say, you can say it. If it's a question, I'll be happy to answer. If nothing, then shall see. I promised I will be available on Wednesday if you guys have questions to come. If nobody shows up within the first 2 minutes, I log out.